The moon, Earth's constant companion in the sky, has fascinated humanity for millennia. While traditionally seen as a celestial body distinct from stars, new insights challenge this notion, suggesting the moon might be far more complex. This paper explores the radical idea, exclusively the theory of L.S. Larkey, that the moon is a white dwarf, the remnant of a star that went supernova eons ago. This theory, detailed in and copyrighted by L.S. Larkey, redefines our understanding of gravity, positing it as a pushing force rather than a pulling one. The implications of this theory could revolutionize our comprehension of celestial mechanics and the fundamental forces of nature. The anomalous characteristics of the moon. Ancient surface rocks. One of the most compelling pieces of evidence supporting the theory that the moon is a white dwarf lies in the age and distribution of its rocks. Lunar surface rocks have been found to be as old as the universe itself, while Earth's oldest rocks are buried deep within its crust. This stark contrast suggests a fundamental difference in the formation and evolutionary processes of the two bodies. On Earth, some of the oldest known rocks include the Acasta gneiss in the Canadian Shield, which dates back about 4 billion years, and the Isua greenstone belt in Greenland, estimated to be around 3.8 billion years old. Additionally, the Jack Hill zircons in Western Australia are some of the oldest minerals on Earth, with an age of approximately 4.4 billion years. These ancient rocks are typically found in the cores of continents, known as cratons, and are located deep within the Earth's crust. In contrast, the Moon's oldest rocks, such as the lunar highlands and orthosites, are believed to be around 4.4 to 4.5 billion years old and are found on its surface. These rocks date back to the early history of the solar system. The lunar Maria basalts, younger volcanic rocks, range from 3.1 to 3.8 billion years old. The exposure of these ancient rocks on the Moon's surface without significant burial supports the idea that the Moon has a different evolutionary history. Lack of a magnetic field. The Moon's lack of a significant magnetic field further distinguishes it from Earth. Contrary to the traditional belief that planetary magnetic fields are generated by a dynamo effect in a liquid outer core, the true nature of these fields originates beyond the 10th dimension. This subtle magnetic field is the heartbeat of a planet, resonating beyond space-time and providing life-sustaining properties. The absence of a magnetic field in the Moon aligns with the characteristics expected of a white dwarf, which would no longer possess the subtle magnetic field necessary to sustain itself within the relative vacuum of space. Surface density. Another intriguing aspect of the Moon is the distribution of its dense materials. On the Moon, the densest materials are found on the surface, whereas on Earth, they are located deep beneath the surface. This anomaly can be explained if we consider that the Moon was once a star that went supernova, expelling its outer layers and leaving behind a dense, exposed remnant. The Moon is a white dwarf. Supernova origins, the epic journey of a celestial body. In the vast tapestry of the cosmos, the story of a white dwarf is one of both cataclysm and rebirth. According to L.S. Larkey's groundbreaking theory of gravity, this journey begins with a supernova explosion, a powerful event where a star's outer layers are violently ejected into the depths of space. What remains is a dense core destined to transform into something extraordinary. In the heart of the galaxy, a star relies on its subtle magnetic field to maintain equilibrium within the relative vacuum of its region. This magnetic field acts as the heartbeat of the celestial body, resonating beyond space-time itself. However, when a star loses this vital magnetic field, it succumbs to the relentless pressures of the surrounding vacuum. The once mighty star is compressed, forced into a state of equilibrium where it can sustain itself. This compressed remnant, stable and enduring, is what we know as a white dwarf. If our Moon were indeed a white dwarf, it would unveil the secrets behind its unique characteristics. Ancient surface rocks, as old as the universe itself, speak of a stellar origin. The absence of a magnetic field, a stark contrast to planets with active magnetic forces, aligns perfectly with the nature of a white dwarf. The Moon's surface density, with its heaviest materials exposed, tells the tale of a remnant core laid bare after a cosmic explosion. This epic narrative, rooted in L.S. Larky's theory of gravity, transforms our understanding of the Moon and its place in the cosmos. It challenges us to see beyond traditional concepts and embrace a revolutionary perspective on celestial mechanics and the forces that shape our universe. Helium-3 abundance. The Moon's abundance of helium-3, a rare isotope on Earth but relatively abundant on the lunar surface, further supports the white dwarf theory. Helium-3 is a product of nuclear fusion reactions that occur in stars. The presence of this isotope on the Moon suggests a stellar origin, consistent with the idea that the Moon is the remnant of a supernova. Redefining gravity. The pushing force. Central to this revolutionary perspective is the redefinition of gravity. Traditionally understood as an attractive force between masses, this new theory posits that gravity is actually a pushing force. This concept fundamentally changes our understanding of gravitational interactions. The key to this new understanding of gravity lies in the concept of the relative vacuum of space. Space is not a perfect vacuum. It contains varying degrees of pressure depending on its location within a galaxy or the universe. Objects in space exert pressure on this vacuum, and this pressure differential creates what we perceive as gravity. Planets and celestial bodies with magnetic fields create what can be described as magnetic field bubbles. These bubbles exert additional pressure on the surrounding vacuum of space, enhancing the gravitational effect. This theory explains why celestial bodies with strong magnetic fields like Earth have more substantial gravitational forces. Another compelling piece of evidence supporting the theory that the Moon is a white dwarf is its unusually large size relative to other moons in the solar system. Most moons are significantly smaller than the planets they orbit, but Earth's moon is remarkably large in proportion to Earth. This anomaly can be explained if we consider that the Moon is not a typical natural satellite, but the remnant core of a star that went supernova. In comparison, the largest moons of other planets, such as Ganymede and Titan, are still much smaller relative to their parent planets, Jupiter and Saturn respectively. The Moon's size, therefore, supports the idea that it has a different origin and nature, consistent with the characteristics of a white dwarf. Understanding gravity as a pushing force allows us to reconcile the anomalies observed on the Moon. The distribution of dense materials on the lunar surface can be explained by the pressure exerted by the Moon's magnetic field bubble, even if it is weak or non-existent. This pressure interacts with the relative vacuum of space, creating the observed gravitational effects. A unified theory of celestial bodies. This new perspective on gravity offers a unified theory that can be applied to all celestial bodies, from planets and moons to stars and galaxies. By considering the pressure exerted by magnetic field bubbles and the relative vacuum of space, we can better understand the formation, evolution, and interactions of these bodies. Evidence supporting the theory. Comparative analysis of celestial bodies. A comparative analysis of various celestial bodies supports the theory that gravity is a pushing force. For instance, gas giants like Jupiter and Saturn, which have strong magnetic fields, exhibit more substantial gravitational effects than their size alone would suggest. Similarly, the Moon's characteristics can be explained by the lack of a significant magnetic field and its origin as a white dwarf. Observational data from lunar missions and space probes provide empirical evidence supporting this theory. the age and composition of lunar rocks, the distribution of dense materials, the presence of helium-3, and the moon's unusually large size are all consistent with the idea that the moon is a white dwarf. Additionally, measurements of gravitational anomalies on the moon align with the proposed model of gravity as a pushing force. Addressing potential criticisms. Traditional gravitational models. Critics of this theory may argue that traditional models of gravity based on Newtonian and Einsteinian physics have been successful in explaining many phenomena. However, these models are not without their limitations and inconsistencies, particularly at quantum and cosmological scales. The proposed theory offers a new perspective that addresses these shortcomings and provides a more comprehensive understanding of gravity. Further research and exploration. To fully validate this theory, further research and exploration are necessary. Future lunar missions should focus on detailed measurements of the moon's gravitational field, magnetic properties, and surface composition. Advanced simulations and theoretical models can also help refine our understanding of the interactions between magnetic field bubbles and the relative vacuum of space. Conclusion. The radical theory that the moon is a white dwarf and gravity is a pushing force challenges long-held beliefs about the nature of celestial bodies and fundamental forces. By re-examining the moon's anomalous characteristics and redefining gravity, we open new avenues for understanding the cosmos. This perspective not only reconciles observed anomalies but also provides a unified framework for studying celestial mechanics. As we continue to explore the universe, these revolutionary ideas will undoubtedly inspire new discoveries and expand our comprehension of the fundamental principles governing our existence. In Gravity and the book, The Unified Theory of You, I elucidate how understanding gravity as a pushing force and recognizing the subtle magnetic fields that resonate beyond space-time can transform our perception of reality. This theory not only sheds light on the enigmatic nature of the moon, but also offers profound insights into the workings of the universe, inviting us to explore the depths of both the cosmos and our consciousness. This theory of gravity, as detailed in, is the exclusive intellectual property of L.S. Larkey and is protected under copyright law.